Human ingenuity knows no bounds, especially when it comes to warfare. While most people imagine tanks as heavy armored vehicles from World War II, like the iconic T-34, or perhaps from World War I, the conceptual foundations of tanks stretch back much further in history, to a time when the technologies we associate with modern tanks didn't even exist. The first tank-like concepts emerged surprisingly early, all the way back in the 15th century. During the protracted Hussite Wars in what is now the Czech Republic, a radical Christian faction following the teachings of Jan Hus found themselves in a difficult position. They had artillery but lacked the knights, armor, and cavalry of their opponents. Necessity, as they say, is the mother of invention. The Hussites devised an ingenious solution. They transformed ordinary wagons into mobile fortresses. Each cart was reinforced with wooden planks and shields, with hand cannons positioned inside. These wagons were then chained together to create a mobile wall with multiple firing positions. This formation, known as a Wagenburg, represented a brilliantly simple concept. Infantry with firearms sheltered behind wheels and metal mounted on a mobile platform. In many ways, this improvised defense system represented the world's first functional tank. It combined the core elements that define tanks even today: mobility, firepower, and protection. About half a century later in Italy, Leonardo da Vinci sketched designs for a revolutionary war machine. His concept featured a dome-shaped turret with cannons arranged in a circular pattern, powered by 8 men inside who would turn cranks to move the vehicle. Unlike modern tanks with their caterpillar tracks, Da Vinci's design relied on wheels, with all movement generated by human power. Interestingly, Leonardo deliberately introduced errors into his blueprints to prevent anyone from copying his invention. Technically, this too was a tank, but an impractical one. The human operators would fatigue far more quickly than they could effectively engage in combat. Nevertheless, the core concept was sound, a protected platform housing both weapons and operators. Throughout the following centuries, humanity repeatedly returned to this fundamental idea of an armored, mobile weapons platform. During the 18th and 19th centuries, engineers designed battle wagons powered by steam engines, but various obstacles always prevented their successful implementation. The steam-scalded operators, the iron components were unwieldy and heavy, horses were frightened by gunfire, and, perhaps most critically, without caterpillar tracks, these early prototypes suffered from extremely poor terrain navigation capabilities. It would take the desperate conditions of World War I to finally transform these centuries-old concepts into the armored behemoths we recognize today as tanks. World War I transformed the nature of warfare in ways nobody could have anticipated. As the conflict dragged on, the front lines became static nightmares of trench warfare. Infantry attacks were decimated by machine gun fire, while cavalry charges, artillery barrages, and other traditional tactics proved ineffective. Armies on both sides found themselves in a deadly stalemate, with soldiers living in trenches for years on end, unable to advance. The British military, desperate to break this deadlock, realized they needed something revolutionary: a vehicle capable of crossing barbed wire, traversing trenches, and providing cover for advancing infantry. What they needed was a machine that could restore mobility to the battlefield. In a fascinating twist of military history, this groundbreaking project wasn't developed by the British Army at all, but rather by the Navy, an organization with virtually no experience in land-based equipment. The development was shrouded in extraordinary secrecy. To conceal the true nature of the project, blueprints were labeled as tanks, the English word for water cisterns. When these machines were transported by rail, they were covered with fabric and disguised as water tanks to fool enemy spies. This simple code name proved remarkably effective and unexpectedly permanent. The term tank stuck and eventually became the standard designation used by militaries worldwide for these armored fighting vehicles. In September 1916, the first 29 tanks, designated as Mark I, rolled into battle. Their performance was far from perfect. They moved painfully slowly, broke down frequently, and half of them didn't even reach their objectives. But those that did make it accomplished what infantry couldn't achieve in years of bloody combat. They crossed terrain that had been impassable, creating breakthroughs in the enemy lines. Though limited in number, these early tanks had a profound psychological impact on enemy forces. The sight of these loud, fire-spitting, smoke-belching metal monsters crawling across trenches was utterly terrifying to soldiers who had never seen anything like them before. The psychological warfare aspect of tanks proved almost as valuable as their tactical capabilities. With this deployment, the tank finally became a battlefield reality. An idea that had gestated for over 500 years finally found its practical application with the addition of an engine, caterpillar tracks, armor plating, and a clear military purpose. And the codename tank, originally chosen merely to maintain secrecy, became permanently embedded in military terminology worldwide, a linguistic legacy of wartime deception that persists to this day. The birth of the modern tank marked a pivotal moment in warfare, introducing a new era of mechanized combat that would reshape military strategy throughout the 20th century and beyond. What began as a desperate attempt to break the deadlock of trench warfare would evolve into one of the most significant weapons platforms in modern military history. During the height of World War I, the Russian Empire desperately sought means to break through enemy trenches. In this atmosphere of urgent innovation, engineer Nikolai Lebedenko proposed a project so audacious that contemporaries immediately dubbed it the Tsar Tank, a name befitting its enormous size and imperial ambitions. The design resembled nothing so much as an inverted tricycle of monstrous proportions. Two front wheels, each nearly 30 feet in diameter, were paired with a small rear roller. The concept seemed logical. The massive wheels would easily roll over craters, trenches, and obstacles that would immobilize conventional armored vehicles. When a wooden and wire model was demonstrated on the carpet of the War Minister's office, it moved with impressive agility, convincing the committee to fund a full-scale prototype. The steel behemoth was assembled near Moscow in the summer of 1915. The main body, positioned on the axis between the two giant wheels, housed two aircraft engines originally designed for the Ilya Muromets bomber. The crew would control the vehicle's direction by adjusting the thrust of each engine independently. The planned armament was substantial, two cannons mounted on the sides and several machine guns providing formidable firepower. The initial test drive began promisingly. The Tsar tank reached approximately 10 miles per hour and easily traversed a field ditch. However, disaster struck when the wheels reached soft, peaty ground. The rear roller, which supported the tail section and engines, immediately sank into the soft earth. The gigantic wheels continued to rotate but couldn't extract the vehicle from the mire. With a weight exceeding 40 tons, the tank was hopelessly stuck. A field supply brigade arrived with shovels to assist, but neither horses nor tractors could budge the stranded colossus. Test engineers identified the fundamental flaw. The weight distribution was catastrophically imbalanced, placing too much pressure on the small rear roller. While the committee discussed potential modifications, the realities of wartime demanded immediate solutions, not another year of redesign and testing. Funding for the project was terminated. The abandoned giant remained at the test site until the early 1930s, when its rusting frame was finally cut up for scrap metal. The Tsar tank stands as a monument to ambition and a reminder that engineering audacity requires not just boldness but meticulous calculation down to the last bolt. It represents one of history's most dramatic examples of how impressive scale and innovative thinking aren't always enough to overcome basic physical principles. In the evolution of tank design, the Tsar tank represents a fascinating dead end, a concept so radical that it captured the imagination but ultimately proved impractical. Its failure contributed valuable lessons to future tank designers about the critical importance of ground pressure distribution, mobility considerations, and the dangers of excessive size. Sometimes the most instructive contributions to military technology come not from successes, but from spectacular failures that clarify the boundaries of what's possible. No discussion of tanks would be complete without mentioning the legendary Soviet T-34, arguably one of the most influential armored vehicles ever created. The story of this iconic tank began in the late 1930s when two prototype vehicles completed an impressive endurance test, traveling from Kharkov to Moscow and back, a journey of nearly 2,000 kilometers without any significant mechanical failures. This remarkable demonstration convinced even the most skeptical observers that the Soviets had created something extraordinary. The T-34 proved that a tank could move quickly, navigate difficult terrain with ease, and consume significantly less fuel than the gasoline-powered models that preceded it. Indeed, the T-34 was revolutionary for being the first major tank to utilize a diesel engine rather than gasoline power. Even the designation 34 has a simple origin. It was simply the year, 1934, when designers first sketched the concept for this groundbreaking machine. By the time Germany invaded the Soviet Union in 1941, fewer than 1,000 T-34s were positioned along the western borders. However, each engagement with these tanks left a lasting impression on German forces. The secret to the T-34's effectiveness lay in its sloped armor, a design innovation that caused enemy shells to strike at acute angles, dissipating their energy or deflecting them entirely. This simple but brilliant feature gave the T-34 exceptional protection despite relatively moderate armor thickness. The T-34's impact was so profound that in summer 1941, the Germans captured a Soviet tank and transported it to a testing ground in Germany. German engineers were so impressed by its design that within a year, they had developed their own tank with remarkably similar contours, directly influenced by their Soviet adversaries' innovation. As the front lines pushed eastward toward Moscow, Soviet factories were evacuated even further east. Entire manufacturing facilities were dismantled, cut into sections, loaded onto rail cars, and transported beyond the Ural Mountains. In Chelyabinsk, workers lived in barracks without proper flooring, yet remarkably, within just 3 months, a new production line was operational in what had previously been an empty field. To maximize production speed, manufacturing processes were simplified to the extreme. Welds became rougher, only the most essential instruments were installed in the interior, and tanks were often painted after field tests or even during rail transport to the front. These compromises in finish quality allowed for dramatically increased production rates without sacrificing combat effectiveness. In 1943, the T-34 received a significant upgrade with a more spacious turret and a larger caliber main gun. This enhanced version could now effectively engage even the formidable German Tiger tanks, provided it could close to medium range. By May 1945, nearly 58,000 T-34s had rolled off Soviet assembly lines, more than the combined production of all German medium and heavy tanks throughout the entire war. The T-34's career didn't end with World War II. These versatile tanks saw action in Korea, Egypt, Angola, and even during the Balkan conflicts of the 1990s. The T-34 represents not just a successful weapon system, but a triumph of pragmatic engineering, balancing performance, protection, and producibility in a package that changed the course of armored warfare forever. Its influence on tank design continues to resonate in modern armored vehicles, cementing its place as one of history's most significant military innovations. When conventional military equipment is unavailable, but the threat of invasion looms, human ingenuity finds a way to create defensive capabilities from whatever resources are at hand. During World War II, two remarkable examples of this improvised approach to tank development emerged in vastly different corners of the world, both born from necessity and creative problem-solving. New Zealand, despite its remote location from Europe, found itself participating in World War II and facing a potential Japanese invasion. As Imperial Japanese naval forces threatened the region, New Zealand needed to consider its own defense. The problem? The island nation possessed absolutely no armored vehicles, with only some antiquated artillery pieces dating back to earlier eras. With American supply convoys taking months to arrive, New Zealand's leadership demanded an immediate solution. The answer lay in New Zealand's abundant supply of Caterpillar D8 tracked tractors, which were commonly used for clearing paths through forest and jungles. Without any proper military armor available, engineers covered these tractors with ordinary construction-grade steel plates, reinforced them with shields, and mounted 6 heavy machine guns on each vehicle. According to the design specifications, each of these improvised tanks would be operated by a 7-person crew. The interior conditions were far from ideal, cramped and noisy, with the diesel engine occupying the same compartment as the gunners. Ventilation was limited to simple holes in the roof. The first field test in June 1942 showed promise, with the makeshift tank successfully navigating earthen embankments and trenches. However, serious limitations quickly became apparent. The vehicle's total weight exceeded calculations, limiting its maximum speed to just 12 miles per hour. The original plan called for producing 30 of these improvised tanks to defend key ports. In reality, only 6 hulls were manufactured, with just 3 becoming operational. By late 1943, the threat of Japanese landings had diminished, and American Sherman tanks began arriving in New Zealand. The improvised tank program was subsequently abandoned, with the armor plating disassembled and the tractors returned to their original civilian contractors. Some of the metal was repurposed for agricultural buildings. Despite their limited combat capabilities, these vehicles demonstrated the impressive mobilization potential of even a small nation when faced with existential threats. A similar but more successful story unfolded half a world away during the summer of 1941, as German forces laid siege to the Ukrainian port city of Odessa. The defenders had almost no tanks, factories were being evacuated, and no reinforcements were forthcoming. Engineers made a bold decision: convert tractors into armored fighting vehicles. The Odessans used STZ-35 agricultural tractors as their base, covering them with improvised armor made from boilerplates, old doors, pipe remnants, and sometimes even cement blocks. This creation became known as the Ni-1, a name derived from the Russian phrase "nai spug," meaning "for frightening," because their primary purpose wasn't to defeat enemy tanks, but to break enemy morale. Remarkably, this psychological approach proved effective. When these noisy, boxy contraptions advanced towards German positions, enemy infantry often mistook them for genuine Soviet tanks. Attacks would falter as panic spread, frequently resulting in retreat. Some of these improvised tanks mounted Maxim machine guns, while others carried no weapons at all. Yet their psychological impact was undeniable, especially during night operations when headlights reflecting off their armor created the impression of a column of genuine battle tanks. The Ni-1 wasn't a triumph of advanced metallurgy or sophisticated engineering, it was a victory of resourcefulness. With nothing more than a tractor, some sheet metal, and considerable courage, desperate defenders transformed agricultural equipment into psychological weapons that helped defend their city against a technologically superior invader. These improvised tanks remind us that sometimes the most effective weapons aren't those with the most impressive specifications, but those deployed with creativity and determination at crucial moments. Humanity has invented countless weapons throughout history, from primitive stones and sticks to nuclear bombs. But during World War II, the United States deployed a special unit that demonstrated remarkable effectiveness against German forces without tanks, artillery, or conventional weapons. This unit consisted of only about 1,000 personnel, yet its impact on the battlefield was extraordinary. What made this unit so special? Their arsenal consisted of inflatable tanks, inflatable artillery pieces, inflatable trucks, powerful speakers broadcasting recorded sounds of moving military equipment, and other deception tools. Rather than combat soldiers, this unit was staffed by set designers, artists, engineers, and visual effects specialists. This unconventional force was known as the Ghost Army, and it represented one of the most creative applications of psychological warfare in military history. The Ghost Army entered the European theater in 1944 with a singular mission: to deceive German intelligence and reconnaissance. They would deploy hundreds of fake military equipment pieces in strategic locations, creating the illusion of substantial American forces where none actually existed. This deception served two primary purposes: either to lure German forces into attacking these phantom positions, or to convince the Germans to divert defensive resources to protect against the non-existent threat, allowing real American forces to strike elsewhere and break through enemy lines. The quality of these deceptions was remarkable. The inflatable equipment looked genuinely realistic, especially when viewed from a distance, whether from the air or ground. At such ranges, distinguishing these props from actual military hardware was virtually impossible. The American specialists even simulated tank column movements by attaching wheels to their inflatable models and towing 3 or 4 fake tanks behind a single truck, creating the impression of an entire armored division on the move. Sound effects played a crucial role in selling these deceptions. Powerful speakers broadcast pre-recorded sounds of metal tracks clanking, engines roaring, and troops moving. Beyond the visual and auditory elements, the Ghost Army created an entire ecosystem of deception, including fake tents, inflatable aircraft, and human figure cutouts. They even generated false radio communications that distracted German intelligence from intercepting genuine American tactical communications. Perhaps the Ghost Army's most famous achievement was Operation Fortitude, conducted several weeks before the Allied landing in Normandy. They positioned their inflatable army near Pas-de-Calais, convincing German high command that this was the true invasion site. The deception was so effective that when the actual landing began in Normandy, German forces were completely disoriented and unable to redeploy their troops quickly enough to counter the real threat. The Ghost Army remained classified for many decades after the war, its remarkable contributions hidden from public knowledge. Only recently has the full extent of their impact become clear, revealing how ordinary rubber and creative thinking became powerful weapons of war. Their story demonstrates that warfare isn't solely about firepower and armor. Sometimes imagination, deception, and psychological manipulation can be equally decisive on the battlefield. The Ghost Army proved that knowing when to inflate a tank could be just as important as knowing how to operate a real one. Desert terrain creates ideal conditions for mine warfare. The dry sand and flat surfaces make everything visible, which is precisely the problem. As German forces advanced across North Africa during World War II, their engineers quickly learned to spot changes in the terrain. If the sand appeared slightly disturbed, if the wind-formed ripples were irregular, it likely indicated something buried beneath, typically an Allied mine. German sappers would then either defuse these explosives or simply navigate around them, neutralizing the threat. Faced with this challenge, British forces devised an ingenious counter-strategy that leveraged the most innocuous object in the desert landscape: camel dung. They began disguising their mines by placing dried camel droppings directly on top of them. This seemingly insignificant detail proved remarkably effective as camouflage. In the desert environment, camel dung was ubiquitous and typically ignored by passing troops. More importantly, disturbed sand around these droppings wouldn't raise suspicion. After all, if camel dung was present, it logically followed that camels had recently passed through the area, explaining any disruption to the sand surface. The results exceeded all expectations. German columns would advance confidently across seemingly clear terrain, only to trigger explosions in areas that appeared completely safe. Mines would detonate in the middle of flat, clean sections where no sapper would have suspected danger. The psychological impact was profound. German forces became increasingly paranoid about every piece of animal waste they encountered. Eventually, German troops began approaching all camel droppings with extreme caution, meticulously checking each one for concealed explosives. Given the abundance of these droppings along desert paths and routes, this precautionary measure dramatically slowed their advance. What began as a simple camouflage technique evolved into a significant tactical advantage for Allied forces, demonstrating how even the most primitive and unpleasant aspects of the natural environment could be weaponized through creative thinking. This unusual tactic highlights a fundamental truth about warfare. Effective strategies don't always involve sophisticated technology or overwhelming firepower. Sometimes, the most successful military innovations leverage simple environmental factors that the enemy has overlooked or taken for granted. The British use of camel dung as mine camouflage represents a perfect example of asymmetric thinking, using minimal resources to create disproportionate effects on enemy operations. The camel dung deception also illustrates how psychological factors can multiply the effectiveness of physical weapons. The actual mines themselves remained unchanged, but their psychological impact was dramatically enhanced by the uncertainty and paranoia the camouflage technique generated. German forces weren't just slowed by the physical threat of explosives, but by the mental burden of constant vigilance against an enemy who had weaponized the most mundane features of the desert landscape. In the harsh environment of desert warfare, where traditional concealment options were limited, this unconventional approach to mine deployment demonstrates the adaptability and resourcefulness that often characterizes successful military operations. It stands as a testament to the principle that in warfare, as in nature, adaptation to the environment is often the key to survival and success. While most tanks are designed for actual combat, deployed to the front lines, put into mass production, and continuously upgraded, there exists a fascinating category of armored vehicles that never saw battle. These weren't built for victory on the battlefield, but rather to test radical new concepts. Some of these ideas were wildly impractical, while others were simply ahead of their time. The Soviet Union, with its massive industrial capacity and engineering talent, produced some of the most intriguing experimental tanks in history. One of the most dramatic examples was the imposingly named Object 279, developed in the late 1950s. This wasn't just any tank, it was specifically designed for nuclear warfare. Soviet engineers reasoned that if nuclear weapons detonated nearby, this tank needed to remain operational. It had to withstand the blast wave without flipping over. To achieve this remarkable resilience, they created an elliptical, streamlined hull and equipped it with 4 caterpillar tracks instead of the usual 2. The stability, off-road capability, and armor protection were all exceptional. However, Object 279 faced several insurmountable problems. First, it was prohibitively expensive compared to other Soviet tanks, making mass production economically unfeasible. Its complex technologies made field repairs nearly impossible, a critical flaw for combat vehicles. Perhaps most damning, it was excessively heavy and lacked maneuverability. There were legitimate concerns that its weight would prevent it from crossing most rural Soviet bridges. Today, this extraordinary machine stands as a museum exhibit in Patriot Park, a testament to ambitious engineering that couldn't overcome practical limitations. As the Object 279 project was shuttered, Soviet leadership in the 1960s shifted focus toward missile tanks. Despite what the name might suggest, these weren't tanks propelled by rockets, though one such design did exist. Rather, they were conventional tanks that fired guided missiles instead of traditional shells. The most famous example was the IT-1, which resembled a standard T-62 tank but with a missile launcher in place of the main gun. The concept seems straightforward. Launch a missile, reload, launch the next missile. Against enemy armor, this approach was theoretically ideal, offering precision strikes at extended ranges. But warfare isn't just about tank versus tank engagements. Against infantry, buildings, or other soft targets, the IT-1 proved woefully inadequate. Its extreme specialization became its downfall, and the project was eventually abandoned. Even more ambitious was the Object 775, a tank that looked like something from a science fiction film. It featured an extremely low, nearly undetectable profile, with the crew positioned deep inside the hull. Its universal main armament could fire both guided missiles and conventional shells, making it theoretically effective against all types of targets. The vehicle represented the cutting edge of Soviet tank design philosophy. However, such advanced technology required an equally advanced level of electronics and precision engineering that the Soviet Union of the 1960s simply couldn't provide. The tank never entered mass production. though many of its innovative technical solutions would later find applications in other Soviet armored vehicles. These experimental Soviet tanks, despite their ultimate failure to enter service, played a crucial role in the evolution of tank design. Through bold experiments, occasional overreach, and technological dead ends, the foundations were laid for the successful combat vehicles that would eventually dominate the battlefield. In the world of military innovation, even failures can contribute valuable lessons to future success. In the annals of tank development, few designs have been as audacious or as potentially revolutionary as the Chrysler TV-8. This extraordinary vehicle represented one of the most ambitious engineering projects in armored warfare history, a tank amphibian powered by a nuclear reactor similar to an icebreaker or nuclear submarine. The sheer intellectual effort invested in this concept was staggering, though ultimately the challenges of transforming this vision into metal reality proved insurmountable. The TV-8 looked nothing like conventional tanks of its era. Forget the rectangular hulls and standard turrets that dominated tank design. This vehicle featured a massive oval turret capsule mounted on a lightweight tracked chassis. This unconventional configuration placed all critical components, the engine, crew, and armaments, within the enormous egg-shaped turret. The turret itself was completely sealed and could float like a boat, fulfilling its amphibious design requirements. Instead of a traditional diesel engine, the TV-8 was intended to house a genuine nuclear reactor. The reasoning behind this radical power source was compelling. With a nuclear reactor on board, the tank could travel tremendous distances without refueling, essentially eliminating the logistical challenges that have plagued armored operations throughout military history. Imagine a tank capable of operating continuously for months without stopping, a commander's dream and a logistician's fantasy. While the concept sounds incredible on paper, deeper consideration reveals a host of troubling questions. How could crew members survive while positioned mere feet away from an active nuclear reactor? What would happen if an enemy shell penetrated the tank's armor? Each disabled tank would potentially create a miniature nuclear disaster directly on the battlefield. The environmental and strategic implications were staggering. Chrysler's engineers proposed various protective measures to address these concerns, but the problems ultimately proved unsolvable with the technology available at the time. Radiation levels would have been dangerously high, and the risks associated with battlefield damage were simply unacceptable. Despite its futuristic design and revolutionary potential, the project was terminated during the development phase. The Chrysler TV-8 thus remains merely a concept, a bold vision that dramatically outpaced the technological capabilities of its era. It stands as a fascinating example of how military innovation sometimes pushes beyond practical boundaries, reaching for capabilities that technology cannot yet safely deliver. The nuclear-powered tank represents a road not taken in armored warfare development, and perhaps for good reason. In the high-stakes world of military technology, not every innovative concept makes it to production. Some ideas, no matter how brilliant on paper, encounter fundamental physical or practical limitations that cannot be overcome. The TV-8 reminds us that the most ambitious engineering concepts sometimes serve their greatest purpose not as battlefield weapons, but as stepping stones in our understanding of what is and isn't technologically feasible. After World War II ended, the Soviet Union found itself with a surplus of tens of thousands of T-34 tanks, many in pristine condition. While a large portion went into storage, many of these formidable war machines found surprising new purposes in civilian life. These battle-hardened veterans of the Eastern Front were ingeniously repurposed for peacetime applications, sometimes in the most unexpected ways. The most straightforward conversion turned these tanks into powerful recovery vehicles. Workers would remove the turret and replace it with a heavy-duty winch. These modified tanks proved exceptionally effective at extracting various vehicles that had become stuck in mud and swamps during the war. With their exceptional traction and pulling power, the tracked T-34 chassis performed this recovery work far more effectively than any conventional tractor could manage. Soviet authorities also repurposed T-34s as specialized snow removal equipment, particularly for clearing airport runways of heavy accumulations. By mounting a large plow directly to the front glacis plate of the tank, they created a snow-clearing behemoth that could handle even the most challenging winter conditions. The tank's powerful engine and excellent traction made short work of snowdrifts that would have stymied conventional snow removal equipment. Perhaps the most unusual conversion transformed these war machines into mobile saunas. Again, the turret would be removed and the interior stripped of military equipment. Workers would then install wooden benches and a steam generator inside the hull. These improvised mobile bathhouses were particularly valued during geological expeditions to the northern regions of the Soviet Union, where traditional bathing facilities were non existent, but the psychological and hygienic benefits of a proper steam bath remained important. Some remote villages received their electrical power courtesy of repurposed T-34s. Though not particularly fuel efficient, these tanks served as mobile diesel generators in areas where the national power grid had not yet reached. The reliability of the T-34's diesel engine made it a dependable, if somewhat wasteful, source of electricity for communities that would otherwise have remained in darkness. The film industry also embraced these surplus tanks with enthusiasm. T-34s frequently appeared in movies, though not always portraying themselves. Filmmakers often modified them to represent other tanks, including German models. With some plywood attachments, fresh paints, and appropriate insignia, Soviet T-34s could convincingly play the role of enemy armor in countless war films, creating realistic battle scenes without the impossible expense of acquiring actual German tanks. Finally, as any Russian citizen can attest, the T-34 found perhaps its most visible peacetime role as a monument. These tanks stand on pedestals throughout Russia and several other countries, silent sentinels commemorating the sacrifices and victories of World War II. What once served as instruments of war now serve as powerful symbols of remembrance. The diverse second lives of T-34 tanks demonstrate the remarkable adaptability of these machines beyond their intended military purpose. From pulling vehicles out of mud to providing steam baths in the Arctic, these tanks prove that good engineering can find new applications long after the battles have ended. The T-34 civilian career stands as a testament to human ingenuity and the capacity to transform the tools of war into instruments of peacetime progress.